All right. So just a couple of quick things. We're not nearly as sort of big of a group, so maybe these rules don't matter so much. But if you're not speaking, it would be helpful if you kept yourself mute so that we don't pick up noise, between conversations and so forth. I'll do my best to try to moderate here. It's going to be pretty small, so I think it'll be pretty informal. There's also a chat window, so in the bottom, if you pull your mouse down, you can see the little chat window there. Might as well pop that open. So if you have like questions while someone else is speaking, or you just want to like keep track of what's going on, or sort of like put down an idea so that we make sure that we discuss it. Just throw it in the chat window, and then I'll try to make sure that I monitor it to make sure to bring it up for folks.
Does anyone else find Walter's fingers to be like a scary spider?
Walter's fingers are scary. What?
It seems
so
like
I have a new laptop for work because my old one died, and it's got the camera at the bottom, which is
okay.
Not a design decision. Sorry.
All right.
And then if you haven't noticed that in the upper right corner, you can bring your mouse up. There's a speaker view and a gallery view. The speaker view will basically show you a large picture of the person who's speaking, and then gives you sort of an overview. Hi, Josh. Gives you sort of an overview of all of the other people in the top corner. If you switch that to gallery view, you can actually see everybody, and it'll just keep sort of like going. It'll do the Brady Bunch sort of thing, where it just keeps people in a grid. So, it's just whichever you prefer. I like seeing everybody, so I usually use gallery. Okay. Any questions before we get started? Okay. So the topic for tonight was basically to just kind of talk about what people have done sort of since the faculty development workshop, and sort of talking about like how things have been going, and whether the faculty development workshop sort of facilitated your work, if you will, and if so, how did it do it? Yep, go ahead.
First, I think Josh, Danny's voice was coming back, fed back through into the system because you weren't muted.
Yeah, sorry, Josh. I should have mentioned this when you kept on. So we'd like to try to keep muted unless you're speaking, because there is a sort of feedback and then sort of the ambient noise and so forth. Yeah.
Or headphones.
Yeah.
Can help.
Thanks, Hunter.
Too. Yeah.
So I guess, the question before the group is sort of, what have you been up to since the meeting? How's that been going? And did the stuff that we did at the faculty development workshop, did that help facilitate that? And if so, how have you sort of drawn on that? Okay. So based on my gallery view, just so I keep track of everything, I will start with Michelle because she is in the upper left corner. And then Hunter, Walter, Josh. That's the order that I have it in my screen.
All right. So you want to know how I've implemented things that we discussed in the pickup workshop? So, for this semester, my main goal was implementing Python via trinkets and Jupyter notebooks into the lab portion of the second semester intro physics, calc-based. And I would say that that at the beginning of the semester, it went really well. The students really, really love the coding, and a lot of them had taken Python before, so it was fun for them. And for the students who hadn't, I built the exercises in a way that they didn't, I told them they don't have to know how to code or learn to code, but really they were learning how to code. And they really enjoyed it also, but it was just the only problem that we have is time. For our lab, we have to do everything within the time bounds of the lab. So we can have maybe like a pre-lab or post-lab exercise, but they're not going to be spending time outside of lab doing that. So we definitely had time issues, and then once we got to circuits, I didn't have as much stuff for them to do just in general with it. So we haven't done anything in the past few weeks. So I would say the students love it and time's an issue.
Clarification question. What do you mean they took Python before? How did they do that?
So the intro to computer science class here is in the Python language. So students that are in a lot of different fields here, interested in engineering, that sort of thing, they're all required to take that. So about half my students had taken that class.
So another question for you.
Oh, go ahead, Hunter.
Trinket is or are you doing GlowScript or other trinkets like Python 3 or and then when you're doing Jupyter, are you doing VPython? What are you doing?
Right. Okay. So thanks for the question, because I actually divided up. So my trinkets, I do mainly VPython, GlowScript, whatever stuff. And then my Jupyter notebooks are pretty much straight Python, you know, with NumPy and Matplotlib and those libraries.
Have you not attempted to do VPython in Jupyter?
So I have, and I've had some struggles and some successes, but my main approach right now is that I want them, even though I tell them they are not learning how to code, I want them to kind of, in the Jupyter notebooks, they are looking more at how the code is working, and the trinkets are generally small little exercises that go along with the lab, like, hey, look at this trinket, what do you predict will happen for this, or something like that. So I just have it kind of broken up into what I want them to get out of it.
So, Michelle, one question I have for you is the materials that you are using in the laboratory, are those materials that you are developing yourself? Are you drawing them from other places? How is that going?
Yes. So so I would say it's a hybrid. So I don't think I've written anything totally from scratch. I don't think I've used anything totally from our PICUP site, but I generally will get an idea from there and edit it to make it work with my class. So because they're kind of being handheld through everything they do coding wise in this class, it's mainly like fully worked notebooks where they have to step through it and change some things. And it's done in a I explain things very thoroughly. So I definitely get ideas from what's on there, and I'll take snippets of code and then add a lot more just explanation. And the trinkets, I have done the same thing, I guess, aside from the one that I wrote when I was there. That's the only one I wrote from scratch.
Do you find that do they like mostly access these trinkets on their own laptops? And have you found any tech problems with this?
Yes, so the only problem I've found is sometimes things getting a little laggy, and it seems to be, so using the trinket with VPython, something that is interactive, like dragging something around, sometimes I see a lag with that, and it seems to be students that are on their laptops, so maybe the Wi-Fi connection, but I don't actually know why that happens. So sometimes like they'll try to drag something, but because it gets laggy, they'll lose it.
Does Trinket support drag, like click and drag options?
Yes.
Really?
Yes.
Okay.
Yeah, Michelle was the one who showed me how easy that was to do at the workshop.
I remembered it being a VPython thing where you were dragging static charges,
yes.
But I didn't remember that it was Trinket.
Yes, that was a trinket, yeah.
Okay.
So just a follow-up question, I guess, was there stuff that you drew on from that faculty development workshop that helped with this, or is it, so one of the things I know about Davidson is they're very supportive of computing in the classroom, right? So where does the support you're getting come from?
So first of all, if I didn't go to the workshop, I probably wouldn't have done any of this semester at all because it's my first semester here. And so if I didn't have, first of all, the materials, so I knew of a resource I could go to that I wasn't writing things from scratch because I wouldn't have had time to do that. And then also from playing with Trinket there, and you guys convinced me that VPython is good. So I think that I took a lot out of it in terms of content, learning VPython. I didn't even know about Trinket before the workshop. So all of those things were a huge benefit.
So I have a question. If your students have exposure to Python before, my, I guess, hesitancy to go down the VPython rabbit hole, I suppose, I think I'm still going to in Physics 211 when I teach introphysics next semester, but my past reticence to go the VPython route is there's a whole lot of magic required to set up the graphics rendering. And by magic, what I mean is stuff that beginning computing students won't understand the function of. So my question is, do you find that your students are able to look beyond the lines of code that do things they don't understand and see, oh, okay.
What are you talking about? Can you please explicate the magic lines of code?
Sure. So let me... Well, I could go pull something up off of my GlowScript Sky site. But for instance, things that set up the, creating a window to draw in of such and such size and creating, certain objects with, syntax calls of, all right, I want a sphere with these parameters and all of the things that are non-physicsy and that are specific graphics calls for which you would need a lot of syntactical background to write correctly.
So for me, because I'm pretty much giving them most of the code, and so for example, the Trinket with VPython that you guys all saw, I'll set one up where it's like 4 positive charges oriented in a certain direction, and I'll say, okay, make one a negative charge. So I make them through the different steps, learn what the parameters to certain functions are. Okay. But it seems that even the ones that have had computing classes before in this class, they're not really questioning so much why. But it might just be because of how I've organized, because I'm not asking them to like start something from scratch. So I asked for feedback on the Python stuff, and I didn't get anything negative on using VPython or the Jupyter notebooks. So
I mean, that's the right outcome, right? You don't want them to focus on little fiddly computer science things. You want them to think algorithmically and think about physics. So
right, and of course, I mean, in computational physics and in other courses, they'll get into details.
Walter, for me this semester, last week in lab they used a GlowScript simulation in Intro Calc-Based E&M, and there I gave them something that was working and had them make some changes to it involving physics stuff, and I didn't point out those lines of code at the beginning, and they didn't ask, and I don't think they looked at them.
Okay, nice.
So, I just want to notice, I don't know if people probably did notice, but Tony's joined us. So welcome, Tony. Tony, what we're doing is we're going sort of through, we started with Michelle talking about what have you been up to since the meeting, how's it been going, and sort of what you might have drawn on from the faculty development workshop or even at your home institution to do that stuff. So I think given the time, we'll probably go to Hunter now and ask him. And it's been, we've had a little back and forth. So if you have questions, just kind of jump in with questions of that person. And what I'll hope to do is by 9 o'clock get through everybody. So maybe give everybody about 10 minutes or so. So Hunter, same question to you.
Okay, I'm all in, and I've been doing a few things. Excuse me. So first of all, we had a course ad deadline that was October something or other, and we made that. So we created a 2-credit sophomore level lab course that will be required for all physics majors and minors. And the inspiration was Kinder and Nelson's Introduction to Computational Modeling for Physical Science, whatever that one is, with the Mandelbrot set on the front. And Aaron Titus introduced me to that book. I bought it. It was only $25, and I formed a working group with 3 students, 3 upper division students, who were going to do independent study with me. And so we meet. We have a regular class time that we meet, and I basically added to my teaching load by having this meeting. But we're burning through that book, and I'm very pleased with it. And you know, so I'm happy that we're now going to have an official, you know, channeling all the physics students through some kind of Python training. Meanwhile, I'm teaching 2 courses. One is a sophomore level waves and heat course, so quote unquote 3rd semester intro calc-based. And I have made some trinkets that I've used, and I've embedded them, you know, in some cases with code and output side by side, and in other cases with output only, embedded them into my course management system, and put them into this kind of lessons tool that I don't really know how to use, but in any case, it puts the trinkets in sequentially. And what I've done is just say, you know, bring your computer. That's another problem. Bring your computer to class, you know, share if you can, and just open these simulations and have them there while you do tutorials in introductory physics. And so I'm trying to design trinkets that are as closely aligned with the tutorials as possible. So what I have is simple harmonic motion, superposition and reflection of pulses, and then I have another set of trinkets for my own worksheet called Applications of Superposition, which is standing waves and beats, and that's what I presented on in the workshop. So it's, you know, manipulating the trinkets so far has been totally opt-in with no accountability. And the idea is that, you know, I sort of have come to believe in educating the student community while the students actually pass through the student community, that there can be incremental development of the student community as a whole, like as an organism, while the cells, you know, are born and die type of thing. So, you know, I'm introducing the trinkets and the Python when there's no reason to get angry about, you know, or frustrated with the effect of this on your grade. They're just sort of having the opportunity to mess with the trinkets to sort of help check their answers on the tutorials and things like that. Meanwhile, also I learned that double E's and math majors have this one computer science course that's required at our university. It's taught in C++, and it's of limited use to developing skills with Python. And so I think we kind of made a bold move in the physics department compared to like engineering and math, where we're not going to rely on computer science to do the work for us. We're going to teach our own course. Okay, meanwhile, I'm teaching quantum at the 4,000 level, and I quickly, we started with trinkets and quickly outgrew them, not because the students understood everything about them, but because there were things that I needed programs to do that trinket couldn't do. And I expressed some of my journey with that on the Slack channel. We've had some growing pains also with Jupyter, you know, getting the right version and just knowing what version of Python we were doing, and being able to import the libraries and understanding how to, you know, every time you want to restart the animation, you got to restart the kernel first. You know, so we learned kind of the hard way, but now we know how to do that. And mostly what I'm giving them is programs that already work, and I'm asking them to augment them with some time dependence, or, you know, maybe I'm giving them like a single wave and I want them to do some superposition. So they're sort of making another wave and adding them together. But that's what I've done so far. So that being quantum and waves, I haven't really used material that's on the PICUP website because I don't think there's very much there in those topic areas. And that's fine. I'm mostly converting programs that I already wrote last spring in IDLE and adapting them for Jupyter. And I now, like this morning, I adapted a program for Jupyter in like 10 minutes because I now know all of the fixes that need to be made. And I uploaded it to the course management system and had it ready for student use. So, oh, and one more update. I have a student who wants to do a research credit with me next semester, and he really wants to build his own computing experience. So he wants to write trinkets for the mechanics tutorials. So he's going to try to keep pace with the mechanics tutorials and introductory physics while that course operates, and possibly, we'll see if we can build a semester's worth of trinkets, next semester for mechanics.
So Hunter, I have a comment and a question. So the comment is so you have this course that you're teaching, or that I guess not your, well, maybe you're going to be teaching it, which is you're not going to rely on the computer science departments to teach your students how to do computing. And
right.
So we recently required, we had a new department that was founded, this computational math, science, and engineering department, and we recently required our physics majors to take both of their introductory courses. So CMSE 201 and 202, which are essentially introductions to modeling and data science.
Cool.
So I think it'll be super interesting to see where that ends up going. But
how did you find the room in the curriculum for that?
What's that?
How did you find the room in the curriculum?
We actually don't require nearly as much physics of our majors to get their degree as most other large institutions do. So, like, for example, our students can graduate our major with only taking 1 semester worth of classical and 1 semester worth of E&M. So there's kind of a lot of...
How much quantum?
I think 1 semester, maybe 2, but I suspect it's 1. Kind of like 1 of each of the upper level courses, and then some courses. So I think we
have a lot of like core curriculum requirements that are just totally out of our control.
Well, I think what we ended up doing was we've dropped the sort of suggested requirement which all students had, which was taking like CSE 2.0 something or another, and just replaced it with that, and then added 1. So I think we actually only ended up adding one course.
So I want to say one other thing, which is that we discovered that remember when I talked about dropping chemistry as a degree requirement? Well, the School of Engineering has already pressured the chemistry department into condensing 2 semesters of general chemistry into 1 for their engineering degree. So for us to piggyback on that is just a drop in the bucket for chemistry, for physics to join. So I think we're going to do that to make room in the degree.
Cool. Then the question I had for you, which was what's the rationale behind aligning your some of your computational activities with the Washington tutorials? What are you hoping to get out of that?
We are trying to, so I shouldn't say we. My intuition is that it will help bring balance to the force. That we have that there is too much emphasis on the tutorials right now in our introductory course. And there's too much of a sense among the students doing them that it is not real physics. And part of the reason it's not real physics to them is because they're not manipulating numbers. But if you are manipulating a computer program, you are manipulating numbers because the computer is manipulating numbers. And so I'm just testing it out, just in an exploratory way. I'm not going to regret, the effort that we put into making trinkets for all the mechanics tutorials. I'm just sort of going to try to keep my ear to the ground and see if it improves student affect in terms of the tutorials. I recently had this kind of epiphany that the tutorials it doesn't matter that the tutorials are hard. What matters to the students is that the tutorials don't look hard. They don't look STEMmy. They don't look elite because they're not using symbolic, representations that would impress their friends. It looks like, I think it looks like it's dumbed down, and I think that they don't appreciate that the form of it is actually pretty abstract and challenging.
I'm teaching intro astronomy this semester, and this is astronomy 101. There is, most of my students can't even do algebra, and I have similar experiences with the tutorials that the students, I think, often.
Are you talking about astronomy tutorials?
Yeah, the Ed Prather astronomy tutorials.
Right. Okay.
And the students have a similar experience of not realizing that beneath the non-threatening presentation lies actual, real, meaty reasoning skills that they need to take.
Yeah, that's very, very interesting, Hunter. I mean, I think it would be interesting to see how that ends up playing out, because I think there's a sort of added component of the visualization that seems like it could really help facilitate that conceptual reasoning that the tutorials are trying to get at.
Yeah. I really like the idea of computational tutorials. I mean, I think, what you said, this idea of, okay, let's, we know that the theory is a significant part of the physics, and that the numerics is not that big of a deal, but you're having the students work in a professional STEM mode where you use human brains on the theory and you use computer brains on the numerics. So in one way, it parallels what they're going to do in the future. And I think it's also, I think it's great. It's wonderful.
Other questions for Hunter?
Am I hearing any skepticism from you, Danny, on this?
Me?
Yeah.
No. I think it's. So I hadn't thought about sort of aligning the computational activities with existing sort of activities that are known to work relatively well. And I think it's interesting. The reason I asked about the rationale is because I was interested to know, why you want to align them. We don't use the tutorials here.
Right.
So I don't really know, we actually we use them in Colorado, but I wasn't involved with the intro courses. So I'm not really sure what students' perceptions of the tutorials are. And so your rationale to me makes a lot of sense. Right. Because it seems like worksheet work, right? That's what it is. It's worksheet work.
Right. And it's not only that, it's words. And, I remember, I think it's just it's a very powerful message that I think some of the students get from the tutorials. The fact that it's words, they're like, this should not be hard. Why is this so hard? But the faculty just we have a blind spot on that. Like, why do you think it shouldn't be hard? So
did you say that you did a wave superposition trinket?
Yes.
Would you like to share it with me?
Sure.
Okay, that falls in line with what I'm doing next week.
Put it on Slack, Hunter.
Okay.
Can I make a comment? So we have a burgeoning learning assistant program at UCLA that I'm using right now, 12 learning assistants in the mechanics course that I'm teaching. And something you said, Hunter, gave me a great idea, which is using learning assistants to write trinkets for students in the class. Because I think the learning assistants themselves will learn some programming, which is great, but they're also ideal people to write trinkets because they have taken the class before, so they understand the physics to some extent, and they interact with the students a lot, so they know what they're confused on. And I'd love to get my LAs to write some trinkets for that class, and I think I'm going to try to do that.
Sorry, could you define learning assistant for me?
Oh, yeah, sure. In our case, we have this program where students who have taken a class in the past, undergraduate students, can sign up for a course that is a full 4-unit class. It's officially, I think, upper division physics credit, if I'm not mistaken, but I have to check on that. And they go through training on pedagogy for facilitating group work and discussions, and they meet with me once a week, and they hold office hours. They do a lot of the things that TAs do except for grading. And they get credit for this, and then we actually have funding now to have students return as paid learning assistants if we think they did a great job. So that's at least at our school what we're doing.
I'm very interested to hear the outcome of this experiment because I'm teaching computational physics in the fall and I teach intro physics in the spring. And one of my best computational physics students is a sophomore level physics education major, and she's very good, and I may try to recruit her. So I typically recruit learning assistants for my intro class out of my computational physics class, just because it's a convenient source of people who are good at physics who know me. And I may try to recruit her as someone to help develop things like this. And I might try to talk to the physics department and see if we can do an independent study and get her credit, or talk to the education department and get her credit for something she needs. So I'm very interested to hear your outcomes there.
Great stuff. All right, so I think we'll shift to Walter and ask let me see if I can repeat the question. So what have you been up to since the meeting? How's it going? And what did you draw from the FDW or from your local institution to sort of help that work?
Well, so my response is going to be sort of atypical. I'm teaching an introductory astronomy class where the students, if you ask them to, okay, wait a minute, so the force depends inversely on the square of the radius. This is just, that's very difficult for them. So this is a general education astronomy class. It's very humanities oriented, having them write papers on astronomical culture. And, it's a great experience, but it's not the sort of thing to which computational integration really applies. It's not a STEM class, really. And I'm also teaching a computational physics class where, so this class I'm teaching very similar to the way that I taught it last semester. The department and the students really liked what I did last semester. They gave me an award for it. So I'm like, I'm not going to change it. I've got enough on my plate already. I've got these 600 astronomy students who are trying to eat my face off. So that class, I am, so actually tomorrow I'm going to give them an assignment. So if you look on the PICUP website, I wrote a long exercise set on the vibrating string. That is going to be a 3-week project for my computational physics students. So I can give you a link to the PICUP website if you'd like, or I can give you a link to the assignment that I gave last year. Does anybody want those links?
Walter, go ahead and drop them in the Slack channel here. That'd
All right.
be great. Yeah.
Well, I'll do that after I'm done.
Yeah, no worries. You don't have to do it now, obviously, but
Yeah, right.
that's a good way of keeping track of it for all of us.
Sure. So that exercise set I'm actually pretty proud of. I wrote that as kind of an audition for PICUP, and I'm doing some. So I want to introduce the thing that I want feedback from you guys on, which is there's a common pathology that has been identified by several people in physics major training, and other STEM major training as well, but specifically physics majors, and it's the ability to internalize what exponents mean. So there's this constellation of skills that all go together that everybody assumes that someone else has taught the students and no one ever gets around to it, which is to truly internalize what a logarithm means, what an exponent means, what power law scaling is, what a log-log plot tells you, and most crucially, what a Taylor series is and what it does for you. So all of these ideas are related, right? They're related by this idea of understanding exponential dependence. And nobody ever really teaches this, not even in grad school. I remember hearing some of my the graduate students at Syracuse lamenting that there was this problem on the quals that they couldn't do because, or it was lamenting something in his StatMech class. He said, there's this thing and this thing, and then the professor expands the numerator to second order and the denominator to first order, and I know what a Taylor series is, but I don't know why he did that. And this is a good student. So I've noticed that in computational physics, there is a lot of power series behavior, power series dependence on step size and stuff like that. So I decided, I'm going to teach this as a secondary learning objective in my computational physics class. So we make plots of, log-log plots of error versus step size, and we're going to, when we do the vibrating string, make log-log plots of deviation from ideal period as a function of amplitude, because it's really nonlinear, and you see those nonlinearities when you do it numerically, which is really cool. But I said, I'm going to, just for grins, make an inventory, a force concept inventory style inventory on understanding Taylor series and understanding power law reasoning. I'm going to paste this into the Zoom chat if anybody wants to go take a look at it. So I gave this to my students as a pretest, and I'm going to give it to them as a post-test. Kind of FCI style. I don't claim that this is any sort of research vetted instrument. It's just one that I wrote for my own edification. And if anybody cares, then I'll work on, getting other people to look at it. So I wrote this thing, and the pretest results were abysmal. I mean, basically nobody knew what a log-log plot was. Nobody knew what a Taylor series was. It was terrible, which is what I expected. I knew this was a problem going in. But the students are getting good at this. They're getting better. They see that, so this straight line lies above this straight line. So that means, okay, you look at the slope and figure out the scaling. The separation tells me the factor. You can see that the plot for the midpoint rule lies below the plot for the trapezoid rule, because the error differs by a factor of 2 in the small bin size limit. So all of these things that I'm talking about, the reason I'm talking about this is in a computational physics class, there's not really a computational integration challenge because that's what you're already doing, right? So I'm teaching the students, so we're using C because I feel like you need to know a language like C or Fortran to be competitive in the job market, among other things. Many of my students actually are computer science students. This is the interesting thing. Many computer science students saw the simulations that I used as lecture demos last semester when they took intro physics with me. So you got to take intro physics to get a CS degree. They saw the simulations that I did as lecture demos and signed up for this class wanting to know how to make those. And maybe half of those people have dropped the class as they found out that it was a serious amount of work. And the other half are loving it, which was very interesting to me. I have one of my students in my computational physics class is doing the assignment in Java. One of them is doing all the assignments in Python because they know these languages. And they're kind of making this point, the pickup point, that computational skills are language agnostic. So that's going on. I'm actually, the students, they're now beginning to really sink their teeth into the meaty physics things. So let me see if PICUP screen sharing works. How do I do this? Zoom screen sharing.
On the bottom there should be a share screen button right in the middle. So if you scroll down or move your mouse down.
Yep. So I actually have not spawned the window that I want to share. So let me do that. One second. I guess you can see my whole screen, but this window with the little planets orbiting each other, the three-body problem, it was their homework for last week. So they're doing this, and they're getting some very interesting knowledge about the phenomenology of orbits that they didn't have. And this is the really interesting pedagogy thing to me, is I haven't lectured them or presented to them the phenomenology of orbits. I've just said, this is Newton's second law of motion. This is Newton's law of gravity. Now go simulate it. We can, just as a first thing, we can figure out the conditions for a circular orbit of Earth around the sun. So do that one just to make sure your code's working, and then make an elliptical orbit. Play with it. Explore the phenomenology. And now they're doing, I didn't tell them what initial conditions to use. I just said, try to make a planet with a moon going around the sun, going around the star, and they get to investigate the phenomenology on their own, and I'm very interested to see what they write in their reports. Another thing that I have to talk about, though, is, let me kill this guy. and go back to the Zoom thing. Oh, is it even sharing my screen?
I can still see your screen.
Oh, okay. So let me then kill screen. Can you see me now?
Not yet.
Okay. How do I unshare screen?
If you go back to Zoom, you have to click, I believe, share screen. And actually, wait, I can stop it. Ah!
Oh, okay.
No, wait, no, I can't.
Yeah, when I click share screen, it just tells me the options that I have to share again.
That's weird. So I can share screen really quickly, and then I think I can.
Oh, there it is at the top.
Oh, did you get it?
Yep, there it is.
Okay. Apparently, I can share screen and kill your screen sharing, which is interesting, and it seems like an abuse of power.
So yeah, that simulation is that's what they did last week. But the department is actually very, very interested in talking to me about computational integration. The director of undergraduate studies is significantly on board, as is the department chair. And they want to talk to me, I think actually tomorrow, about doing computational integration in the next upper division StatMech class, because that is a class where the phenomenology is often hidden behind impenetrable Taylor series that nobody really knows how, or series that nobody really knows how to sum. And it's really difficult to grok the phenomenology in StatMech without having to dive through a whole lot of math that some of our students aren't prepared to do. I mean, I certainly wasn't at that place in my career. So I'm going to talk to him about doing a very large-scale integration. And one of the models that I have in mind, this is something I'd like to get feedback on, is the idea of a computational lab that goes with a class, where they have activities possibly meeting at a different time, taught by a different faculty member, okay, now let's apply the things you've learned in your class where you do theory, and let's go model something on the computer and do an experiment. It's just a simulated experiment rather than a physical one. And I'm going to propose this to them as a way to get around the professor buy-in thing.
I thought about that. And at one point I had the scheme of having a lab class go with each of the upper division core courses.
I like that.
I could avoid the buy-in problem. But what we settled on as a department was that it would be better to just force all of the students through it at a sophomore level. And then at some point we'll communicate to the faculty, hey, this is what all the students are able to do. Please take advantage of it in the upper division courses.
And I'll admit significant ulterior motives here in proposing this, because I'm still angling for a permanent position at Syracuse, and if I propose some sort of scheme that involves something taught by a separate faculty member, I can say, hey, you should keep me around and let me do this because I'm useful.
You want to make yourself indispensable.
Yeah, exactly. So I know I've rambled for a while, but yeah, so astronomy has no computation, and computational physics is exactly what it says on the tin. It's using C and animations like the one I just showed you to do various physical systems. We're doing the vibrating string next. For their final project, they will do either n-body molecular dynamics, either the pseudo-ideal gas with the 12.6 potential, or they will do simulations of a vibrating membrane in 3 dimensions with physical nonlinearities. And students who really get into that can do some pretty fantastic things.
So, Walter, let me suggest that if you want feedback on particular activities and stuff, that we try to make sure that goes into Slack in addition to someplace here, because there might be people who have not been able to join that could give you feedback or talk with you about it. I'm thinking of Sean in particular. I know that he and I have talked a little bit about activities for like advanced E&M, but I think there could be like having that threaded conversation there might help others too.
Yeah, I'll do that. I've been sort of completely buried by just trying to give 600 students individual attention is a life-consuming endeavor.
Any other questions for Walter? Okay, Josh, maybe we'll go with you.
If I can say, so I do need to run. I had to leave rehearsal to come here, and we have a concert with the symphony in 2 weeks. So,
well, thanks for joining, Walter. Thanks for getting involved.
Of course, yeah. I mean, this pickup is fantastic, and I'm so glad to be working with you all.
Appreciate it. Cool. Enjoy your rehearsal.
Will do.
Okay, Josh.
Okay, so this quarter I'm teaching 2 computational physics seminars. One that is concurrent with mechanics for scientists and engineers, intro mechanics, and the other one that is with math methods, which is an upper division math methods class for physics majors. And the seminars meet for 2 hours every week. And there are 15 to 16 students per seminar. They're honor seminars, so each of them was an opt-in kind of thing. I sent out a survey to all my students before the course began and asked for how many people were interested in taking a seminar, and I have to say that it was pretty amazing how many people were. In my math methods class, over 90% of 85 students said they wanted to take the seminar, and there are only 16 spots. And in the mechanics class, I think it was around 60% said that they were interested in the seminar. So there's really no problem for me finding interested people, which is encouraging.
Can you say again how the seminar was defined?
Sure. Each week they meet in a room that's kind of like a lab style setting, and they work on some computational problems. I was going to elaborate on this too, which I can just do right now. Basically, they come to a room and they pair up with someone and they work on a Jupyter notebook for 2 hours. The topic of the notebook is typically related to the course material in some way. So for mechanics, for example, there was a notebook about projectile motion where they had to find the range of projectiles on various hills, for example. I've structured things so that every group contains one programmer who's self-described as being somewhat expert in programming, and one person who self-describes as being a complete novice in programming. And that's been an interesting experiment that I can speak about the results of. But that's the structure. Is that what you were looking for?
I guess I also wanted to know what the students thought they were opting into.
So it's a 1-unit course that only students who are signed up for either of those two, either the mechanics course or math methods course, are allowed to sign up for. And it's graded. The course itself that they're signed up for is either 4 or 5 units. So basically, you tell them if you're interested, you can sign up. It's an honor seminar. They can sign up for this honor seminar optionally. I tell them it's only a 2-hour week commitment. There's no homework or anything like that. They just come and do the lab style notebooks, and they get a credit for it.
Why do you think it was so appealing?
I asked for comments, and I only got a few of them about that question. So I'm not entirely sure what it is for most people, but I will say that for the people who commented, there was a very wide range. One person commented that he believes that learning about physics in a computational setting helps him understand the physics because he thinks algorithmically typically anyway, and so he wanted to take the seminar for that reason. And generally speaking, it seems like students are excited about the prospect of learning Python, which is what I'm using for the course, because there's some perception that Python is a relevant language and a useful skill to have in the workforce. So I think that's part of it too. So anyway, I've been doing this for the past few weeks, and I've done a lot of experimentation with the format. I wrote something at the PICUP workshop, which was an exercise or a Jupyter notebook for learning Euler's method for numerically integrating ODEs. And I have to say that, interestingly, that has been the most successful activity. And I think part of it was that I got a lot of really good feedback from people who have done this before. So maybe also from our discussions with each other, I got some really good feedback, and I think that has helped a lot. I will say that one thing I'm interested in getting feedback from other people on is, so I've tried this thing of mixing a reasonably good programmer with a novice programmer so that they'll either help each other or cause the programmer who knows a lot to slow down and explain things to the other person or whatever. And I've gotten mixed results. Like in some groups, the person who's kind of good at programming will get really frustrated and want to go really fast. And in other groups, I had this one group where the person who knows Python pretty well is like really into explaining everything to his partner, which is amazing. They have these like super awesome long conversations where he's learning things, he's teaching things, they're looking up random Python functions online, and he's telling her what like recursion means and all this stuff. Like it's totally beyond what I wanted them to talk about, but it's awesome. And then there's another group where this guy is just like, I literally, when I walk around, and there's an LA there too, when I walk around and ask him like, so what have you guys been doing? He looks completely disinterested, and he's told me that he already knows all this stuff, even though he definitely doesn't, and he looks really frustrated, and his partner is slower than he is. And so I'm interested to know, ways of improving that, because I think it's valuable to have that mixture of skill sets, but there's obviously challenges to that too. So if people have ideas for that, I'm very much open to feedback.
So I will say that because I do my Python stuff in a lab, they're already working in self-selected groups. And I found that those groups, we have different types of pairing. Like sometimes there's an expert and a novice. Sometimes there's people that both don't know what they're doing. But those groups seem to work together really well, I think, because they were self-selected, so they knew that they wanted to work with the other person. So, I mean, I don't know if that's the best answer, but if you have someone who's really good and doesn't want to help somebody else, then they probably would want to work with someone who's more of an expert than a novice or something like that.
Have you rotated any of the pairs, Josh, or do you have any plan to?
Yeah, actually, my learning assistant suggested rotating them, and we did. This last week, we rotated so that, in fact, we tried this thing of pairing the more expert people together and the novices together and see what effect that would have. And I can't say that I've noticed an enormous difference, actually, interestingly. Like, I don't know, I can't tell, basically. It still seems like in a lot of the groups, they're either there's someone frustrated with the other person, or they have a great dynamic. It's kind of strange. I don't know. I don't know what to make of it. But
can I ask to what extent they're working together? Like, do they have one computer and two people?
They have one computer and two people. And actually, another thing I've been doing is, so for the first session, I required the expert programmer not to touch the keyboard at all. So this was doubly frustrating for that person.
Yeah,
but,
that would be frustrating.
That was just, I was interested to see the outcome of that. But now what I've tried is I have points in time during the seminar where I'll say out loud, okay, now switch programmers. And so they are both required to touch the keyboard for a certain amount, basically half of the time. And so I'm trying to structure it so that they're required to work together on some level, in the sense that they need to cooperate to finish the task. But of course, as I've said, this leads to some frustration. So, there seems to be a trade-off that's unavoidable, but I don't really know if that's true.
So our solution to your problem, I think, not to say that this would work for you, but in our department, is to promote teamwork as an explicitly taught and valued ability, that employers are looking for. So I would say, if you think you're such a hot programmer and you're so frustrated with your dumb partner, then you're just not very good at teamwork. Do better. I wouldn't say it like that, but because I'm nicer. But it's something that they need to learn how to do. And like part of interviews are, I mean, from what I understand, because I never had a real job, part of industrial interviews are about trying to find out if someone is a real jerk and doesn't have any patience for explaining their work to other people. So we just have a lot in our department to build a spirit of cooperation and working together.
So does that mean on a practical level that you expose students to a lot of like explaining its importance, or are there more embedded things in the structure of what they're doing and like the activities that supports that idea? Like, do you tell them a lot teamwork's really important, or is there some other more subtle thing that's going on?
We tell them and we direct them to do it a lot. And also, I mean, I don't know, it catches on. Our LA program is overwhelming, you know, in terms of its presence in the physics department. It sort of has ruined everything, you know. And so they're, you know, sometimes they need explicit encouragement, like, okay, the homework is really hard. Well, the homework is meant to be too hard for you, you know, for any individual. So you're supposed to work together, you know. And there are other structural things that happen. In upper division courses, I have students turning in their work electronically in the course management system in a way that it's visible to the other students. You know, so they're seeing each other's work. They're expected to look at it. I'm counting on them to look at it, you know. So it's not about keeping secrets and climbing over others and doing the best you can individually, you know. So.
I see.
Yeah, I would just amplify what Hunter had said, particularly about the teamwork aspect. I mean, one of the big things that we've done in our intro course to sort of ensure that there's some equal use or equal engagement with the computer is to tie the group work aspect and the sort of the teamwork and facilitation to a student's assessment in class that day, right? So that they're getting both feedback about how they're doing and they're getting some numeric score associated with that. Yeah, if you're interested in more about that, I'm happy to tell you about it. I mean, some other time, because we found that by doing that kind of formative feedback with some scoring, seems to bring everyone into it, right? So even the people who could, let's say, breeze through the problems, right? They're being held accountable for the understanding that the group has.
I see. Yeah, I've definitely considered some sort of grading scheme in which their grade depends on the grade of others that they're working with in some way. But yeah, I've never tried that, and I don't really know anything about how the outcome of that would be. So I would be interested to hear, like, you know, what your experiences with that have been.
I'll just add one thing, that one of the things that I do at the intro level is I have group. So I have 2-phase exams where they're individual and then group. When they do the group exam, I mean, there are different ways to do it, but in my class, everyone still gets their own group exam grade. Like, you don't have to agree within your group. You're just discussing the questions and getting their input, and then you're still putting your own answers. And there's no risk. Like, it can't possibly lower your grade. I have a group exam guarantee. You know, that if your grade were to go down, I'll just apply your individual grade twice. You know, but to me, it's been very compelling. The level of engagement, you know, that they have with each other during a group exam, just very pleasing. It's like, oh, I wish every day could be like this. The urgency of figuring out each of these questions, you know. So I'm happy with that as another device.
So yeah, I can't recall if I was supposed to speak about other things. One other thing I didn't say is I've been using Sage Math Cloud for this honors thing, and I have to say the interface of Sage Math Cloud is a little bit clunky at times. Like, I don't know, it's a little not necessarily the most intuitive thing, but But I also have to say that it is nice to be able to, for example, go into a student's notebook simultaneously with that student and help them with code, for example, which you can do. And, you know, the grading functionality is pretty nice and stuff. So I would say I'm reasonably positive about Sage Math Cloud if someone is interested in doing a cloud-based course management thing for computing.
Is it, how Python-y is it?
You can code in Python. I mean, basically you have access to a Linux terminal when you're in Sage Math Cloud, so you can technically compile anything you want, for example. You just have like a virtual machine somewhere. But there's a lot of built-in Pythonic stuff. Like there's Jupyter that comes standard with it. They have a bunch of different Python distributions installed standard. You can edit either in the Jupyter notebook, or you can edit in another window and compile your code. You can even write in Markdown in separate files. You can write in LaTeX in separate files. It's kind of like a cloud-based, all-encompassing computing platform, which is, I think, what they want it to be. So
I remember you talking about it in Wisconsin, and I think it was just like way too much for me to handle at that point. So
yeah.
I'm feeling comfortable with Jupyter, and like maybe in another round I'd be ready, you know?
Yeah, it's also kind of in its infancy, so I feel kind of like I'm a beta tester at some points. So I don't know if I'd recommend it to somebody who, you know, like, even like myself, who it turns out, who has a big course load to teach. So, you know, I can definitely keep you updated on how I feel about it, but at this point I would say if you're comfortable with what you're doing, then just keep doing that.
Cool. Any other questions for Josh? I'm sensitive to the time, so I want to make sure that Tony has a moment to share. Okay. So Tony, you're aware of the question, and so we'll let you go. And you're muted right now, so you probably want to unmute yourself.
Oh, so yeah, I had one question for Josh. The students you're teaching for the last course that you talked about, who are they, and do they? I just wanted to find the demographics. Are they computer science, or I just wanted to know that.
There's one honor seminar that I'm running alongside mechanics, and those students are really mixed. There's computer science majors, engineers, physicists, all that stuff. And the other one is for math methods for physics, so it's basically only physics majors. And I will say something really interesting about that now that you mention it, which is in the first week, I gave both sessions the same Jupyter notebook to do. And most of the students in the one for math methods are, you know, like sophomores, juniors, or seniors, and the students in the other one are all freshmen and very mixed. And the ones in the mechanics sort of lower level one, like, breezed through the tutorial. Like, they did everything correctly really, really fast. And the physics majors took about double the time. And I don't know if it's because they were just more detail oriented and something like that, which seemed to be sort of the case, but also it might have been that their programming ability wasn't as good because there's some computer science people and other people in the other one. So it was very interesting to see that the students in the quote unquote lower level class did a much better job, much faster than the physics majors did.
Cool.
Let's hear about your life, Tony.
Oh, okay. I haven't been out too much. Just teaching a couple of classes here. I've been teaching university physics, which is a calc-based class, and then college physics, which is algebra-based, and I just added an extra one, astronomy. Well, it's science 103, so I have all these 3 classes that I'm teaching. So it's pretty busy. And I am not doing trinkets or any of that stuff. I'm not doing trinkets. I'm not doing glow script. I'm still with VPython. So I experimented a little bit with glow script, and it didn't go too well. So I guess one of the other things was basically maybe I didn't have enough experience with GlowScript, and I figured, well, there's no need to just make it a bad experience for them.
Wait, so you were using classic VPython?
Classic VPython.
And you're not able to use, you had some bad experiences with Trinket or GlowScript?
Not Trinket. I never used Trinket at all.
Okay.
But,
what happened?
There was a little GlowScript. We just made one little error, and the students got frustrated about that.
What was the error?
It was mostly, you know, when you're using VPython, your vector, if you put a vector there, it's very clear that you either have a vector or you don't. But sometimes GlowScript is not going to tell you whether that's a vector or not, and that can be frustrating. So it wasn't a major thing, and my students weren't really that frustrated, but it just felt easier to actually go back to classic VPython because it was already loaded in the computers. So I've been doing classic VPython for the past couple of weeks, and yeah, just the regular way that most people do VPython is they have little exercises. Sometimes they have a minimally working program, and they give it to students and they do it. Or alternatively, there are times when you have a program that can be handled in one class period, like modeling a car on a truck, you know, things like that. So you can do that within one class period, and that's okay. Or you can give a minimally working program that you keep that you add on and then answer a couple of questions. And it's been going well. And the students, I had a bigger class than I usually have, like 25 students. So the space was also an issue, but they've been working in groups of 3 or 4, sometimes in groups of 2. And occasionally you get to hear them saying they like this VPython. But most of them are like, Tony's just making us do these things and we have to do it. So there's nothing we can do. But a couple students, at least 5 of them, seem to have an understanding that this is good and that they like it. One of the students is a girl who's going into biochemistry. She likes coding and she loves that. And then there are a couple computer science people who like it too. But other than that, they just kind of keep going, you know. They're not too unhappy, but they're like, I wish I wasn't coding, but they know that they have to just do it because it's good for them. It's like eating vegetables. So what can you do? So, do you guys have any questions for me?
I just wanted to make a comment that I think the error feedback on GlowScript and Trinket is really not acceptable for student use because it's just really not very informative. You have to know a lot about what could potentially be wrong with your program to begin to make use of that error feedback. And I think it was, I don't remember what it was within classic VPython. I think Jupyter error feedback is the best. And so one thing that I have liked about using trinkets is, I mean, I want students to use trinkets that almost work or work, and they're just modifying them, because then you can always reload it, right? And it will return to its working state or its original state, you know. But I don't think I want students who haven't been formally trained in Python to be writing code in a blank workspace in a trinket, because it would be too frustrating, I think.
Tony, one question I have for you just quickly is so this semester you're using classic VPython in the way you have. Have you been building any new activities, or are you working with activities that you had in the past? What does that look like?
Yeah, I haven't been building any new activities whatsoever. I just don't have time to build any. So I've used the older activities that I've had. Some of them borrowed from some guys who've used VPython for a while, and you're familiar with them. Some from Georgia, and yeah. So I haven't really been able to make any new activities. just modifying.
Okay. So again, I want to sort of be respectful of the time we had. We started a little bit late, and people have had a lot to say, which has been great. Does anyone have any other comments or questions or things that we should bring up? My plan is going to be to sort of ask in the Slack channel what would be sort of the next kind of topic for folks to want to talk about maybe in the next month or so. So we can do that sort of separately and maybe bring other people into the conversation. But I wanted to give some space to let people talk about anything else that they wanted to before we closed out. Okay.
Did you hear from everybody?
Yes.
I don't remember hearing from Larry.
Larry's too much of an expert.
Okay.
Yeah, I mean,
Actually,
so
Michelle, if you wanted to hear from me, I'm actually doing similar to what you described this semester. I have intro calc-based E&M, and we did stuff during the first portion of the semester where they were calculating electric field by adding up lots of little bits of charges, and did that in Jupyter Notebooks. And then last week, they were doing charges in a conductor and looking at the dynamics of charges in a conductor and how they end up on the surface and Gauss's law, which is pretty neat. Yeah, that's it.
Thanks.
I have a question that maybe we can talk about later, but it's about Spider. Because my experience this semester with the Kinder and Nelson book that Danny linked is that we've been doing all of our work in Spider because there's nothing there's nothing in VPython in that book, and that was just how the book directs you to do it, and it's been super enlightening to use Spider and to have the variable explorer in particular, because I just felt like we learned so much about how Python works, like just what are the guts of what makes this work. And so I actually have a real understanding of what I should expect. You know, the program, Python and VPython are much less magic now than they used to be.
Spider is awesome.
What's
Yeah.
that? Yeah.
Spider is awesome. The debugger and variable explorer. Yep.
Yeah. So I just wanted to say that I mean, I don't know that I wish that it had been part of the workshop, or that, but I just want to throw that to the kind of PICUP, whoever the project management team is. You know, that just some feedback that for me, after the workshop, having that kind of experience through Spider was very beneficial.
I think I did show Spider, but it was very brief. You may not have been at that. I think it was in
Yeah, and I don't know if a brief exposure would help.
Yeah.
You know.
Yep.
It's just a lot of playing around, and just we look at our data all the time. Whenever we're making new programs, learning new things. Oh, what does this look like in the variable explorer? You know.
yeah, cool. I mean, we'll take note of that and see. You know, there might be space for that in the next workshop. Okay. Any other stuff? Cool. Well, I'm going to stop the recording now so I can start